In this video, we will discuss about the consistency of the series for the comparison of two sets of data. The question is, the running capacity of two horses is given below. State which horse is more consistent in running capacity and why. And we are given the 10 data set of running capacity of the two horses, horses A and horses B. For this, to compare the data regarding to the consistency or inconsistency, homogeneous or heterogeneous, uniform, equitable, inequality, for all of these types of comparison, whether the data is uniform or not, consistency or not, heterogeneous or not, we have to use the statistical tool, the coefficient of variation, and smaller the coefficient of variation, data is more consistent and more homogeneous, more uniform. For these variables, the smaller CV leads to the consistent data, and if the coefficient of variation is large, then the data is more unequal, more heterogeneous, and more inconsistent. And in this case, to compare the consistency of two data of running capacity of the horses, we have to choose the coefficient of variation defined as coefficient of variation, that is CV, is equal to the ratio of standard deviation to the mean multiplied by 100%. CV is expressed in percentage, where X is the mean of the series and the sigma is the standard deviation of the series, defined as mean is summation x by n for individual series, and the standard deviation is square root of square of the summation of deviation taken from arithmetic mean to the divided by n. For calculation purpose, we can use this second formula, summation x square by n minus summation x by n ko whole square. For this, we have x series of data and their sum, y series of data and their sum. We need to compute x square and y square. The square of the each variable, and sum, we get the sum of x is y, summation x square, sum of y square. These calculation helps to compute the mean and standard deviation of the data. For horse A, the mean running capacity is computed as x bar is equal to 64.1, and the standard deviation of running capacity of horse A, it is computed as 11.987. Similarly, the coefficient of variation is computed as sigma time x, that is the standard deviation of horse A to the mean multiplied by 100%. It gives the value of coefficient of variation of as 18.70%. Similarly, for horse B, the running capacity of the mean running capacity is computed as 63.6. The standard deviation of running capacity, that is sigma of y, is computed as 14.705, and the coefficient of variation for this horse B is computed as 23.12%. In conclusion, here the coefficient of variation of horse A is 18.7, is smaller than that of horse B. So thus we conclude that the horse A is more consistent in running capacity than that of horse B.